is your code capable of reading through all the files, and at the end, do you have the output latitude, longitude, and AOD 550 filtered for all the files, saved as 3 different matrices? Check, you gotta check on your computer. So run it again and make sure you have those outputs available, okay? Let me just continue setting up here.
Yes.
It actually didn't go through. Sorry. Oh. Okay, so let's, I really want Juan to be here, so he doesn't miss this, and also, forget his name. Barry, yeah, we need Barry. What? Barry Allen. Okay. All right, so you should all have your codes open, run it so that you have your final latitude, longitude, and AOD 550 saved as variable names. Okay, now let me just tell you the big picture. This is the final deliverables, okay? What we want is, 1, to be able to map at least one of these Modis data files so we can see what we have there, right? That would be nice. So create a map showing the AOD. Now we have 608 files. Do not run a for loop and try to plot all 608 at once. I tried it on my computer and it went nuts. It almost blew up, I think. So don't do that. Just choose a couple files and create a map. That's one deliverable. Okay, I'm going to show you how to do that. The other deliverable, and you should probably write this down, is once we've matched AOD from AeroNet with AOD from Modis, we want to compare them. Okay? So most of the work is going to be matching time and location of the satellite data with the time and location of our station data. That's most of the work. But at the end of the day, what we want is a scatter plot that shows AeroNet AOD on the x-axis and Modis AOD on the y-axis. Okay? So something like this. Let's get a blank screen up here. So, one deliverable, so you have scatter plot. Okay? It's going to look something like this. X-axis, you have AeroNet. The ground's, the instrument on the ground. Alright. Okay. It's harder than it looks, actually. Okay, I'm just going to put arrow for AeroNet. ground station data. Fixed location over CCNY. The AOD, aerosol optical depth, 550. Okay? On the x-axis. On the y-axis, we're going to have our MODIS AOD. Why do we want to do this? Anyone have any ideas? Yeah, to see how they compare, right? So let's say we have a bunch of points, and there should be a couple hundred points, right? We wanted to see how the satellite data compares to the ground instrument data of AOD, okay? And now, yeah, there are two lines I would want you to superimpose onto this plot. One of them is the one-to-one line, right? Something like that. Basically, if any points are on this line, that tells you, like if the AeroNet AOD 550 is 1, let's say, on that line, that's where the MODIS AOD equals 1. That's where they're equal. So in an ideal world, if everything was perfect, all these points for MODIS AOD would be on that line. Okay? It's not going to be though. And so you can see that if there are points above the one-to-one line, the one-to-one line is basically y equals x, right? Anything above the one-to-one line means that our satellite data, we have overestimations in AOD, right? Think about it. If my AeroNet is saying that I have AOD of 1, at this point, my MODIS data is saying I have AOD of 5, it's overestimating AOD in comparison. Okay, does that make sense? Conversely, if you're under the line, that means the MODIS AOD is underestimated, right? So that it's nice to have that one-to-one line. And then on top of the one-to-one line, so one-to-one, you have your best fit. So have a linear fit to the points to actually show the relationship between MODIS AOD and the AeroNet AOD. So that's one deliverable. You want to take a picture or write it? You wrote it down so I can erase it? 2 lines. One of them is the one-to-one line, basically where y equals x, where MODIS AOD equals AeroNet AOD. The other line is fitting putting a linear fit to the data. Yeah. Let's see if this capture feature actually works. Give it a second. Okay, the second one, it's easy. Scatter plot. Second one, time series. We have data for MODIS from the year 2000 to 2010. So we want to see all the MODIS AOD data over CCNY through the years, and the same thing for AeroNet. We just want to see how the AOD is changing over time. So a time series plot with both. So there should be 2 curves, one for MODIS AOD, one for AeroNet AOD over time. Time on the x-axis. Okay? So those 2 things, and what was the very first one? Mapping the AOD just to a map, right? So we can see it, where it is in the world. So pretty straightforward, right? 3 plots. Those are the deliverables. Right? Make sense? Yes? Yeah? So the whole trick is, to achieve this, we need to be able to, again, match time and location between both data sets. And that's what we're going to be working on. How do I capture this? Yeah. Wait, I want to see if I can do something here. In 1 second.
No. Today you have the right to, right? the right one.
I want to see how I can capture this so it doesn't get erased.
Yeah, watch it.
Miami, you don't know how to capture that in the ink, do you? Miami? Okay. So this feature here where I could capture the page, screen capture. But it's gonna take it wrong.
Did you reload already? Or you you have to reload it?
It's okay. Alright. Oh, okay. Here we go. Yeah.
Something was here when you open it first.
I think that
So
should
you
work. Let's see.
reload it again.
Okay, it's a little cut off.
Yeah, now it's
What did you run?
Okay. Okay, now I can erase that. Okay, so just in case anyone missed it, first deliverable, scatter plot, comparing Modis with ARNet AOD. Clear to me. Jeez, this board is driving me nuts. Okay. Second, again, just in case you missed it, time series. Time series plot. So what would you have? You'd have time on the x-axis. You'd have a line showing AOD of Modis, another line of AOD for ARNet. Okay? Make sense? It's a second. Let me capture that. Alright?
You erase it?
And then the last thing is the third thing again. So we have a map. You know, maybe, alright, I'm not an artist, okay? Florida, something like that. Alright, yeah. Okay? And the AOD would be something like this. Okay? It's a map. A map of AOD. Okay, in case you didn't write it down or you weren't listening.
First is scatter plot.
So let me just delete that ugly picture. Essentially, we just want to map our AOD. Project it onto a map. Okay, for Modis. Alright? Simple enough?
Sure.
Okay, so let's do it. Everyone ran their code. You have your matrices already in the workspace. Yes?
Yeah.
Mine is still running.
Still running. That's okay. So,
Mine is Word. I don't know why I'm getting this.
Yeah, I mean, that's why
let's do this. I'm going to share my screen from my laptop.
the files.
But it's saved already.
No,
It
it's the file.
And it's not.
need to reload it.
Yeah, the file every time.
Stop sharing here. All right.
Let's see if I can get.
So let's go to my Matlab.
What's button is there?
All right, one thing at a
Yeah,
time.
it's there. Just, it's there.
Let's start with just mapping our AOD data because we have that, okay?
Okay, now you
So-
are fine.
Let's just take the first part. I don't want to confuse you guys. Okay, so how would we map our data? The first thing you want to start with is this function called axes m.
How do you say that one more time? Axes.
Axes m.
Okay.
And you can see it up there on the screen.
Can you zoom in? It's like really tiny.
Okay, let me adjust the font. Now how's that? Is that visible? I know it's cut off, but can you see the font size?
Yeah.
Okay. Taking notes when you and they take pictures. Oh, really?
Here we go. So, don't focus on the inputs yet. Here's the thing, we want to create map axes. Okay, so you're basically telling MATLAB, hey, we're going to start a figure, and it's going to be, you know, a map figure. Okay? So we have to set up our axes, and usually what you want to do is you want to give a range for the latitude and a range for the longitude. Okay? Now, I could specify that range basically by putting in square brackets my min and my max. So for latitude, you would choose your minimum latitude. Choose a minimum latitude. Well, what do we want to choose? Let's say we want to generate maps for every file at some point, and we want to have a window that matches all the others, right? So what we could do,
Before you go on, can you take the chat off of the screen?
it's not on my screen. How's that?
That's perfect. Yeah.
Okay. Thanks for letting me know. So what do we have here? You basically have to set your minimum and max for your latitude and your minimum and max for your longitude. You're basically telling MATLAB what window to plot, what range on a map. Okay? So let's look at the inputs for this function. Axes m, you create your axes. And you can specify multiple parameters. So here's how it works. I specify to MATLAB, hey, for this function, I want to identify my map projection. Okay? So I'm signaling to MATLAB, hey, the next input I enter is going to be the type of projection I want. So I do that, and which type do I choose here? I choose Mercator. They're different projections, right, as you're probably learning in GIS. So this you can change. All right? This is just to let MATLAB know I want to tell you what the map projection is, and here you choose the map projection. Same thing here. Now you tell MATLAB, I want to tell you what my latitude limits are going to be. If I'm looking at New York City, that's at about, what, 40 degrees, let's say? Yeah, more or less. So let's say I want to look at 35 to 45, right? 35 degrees north to 45 degrees north. I tell MATLAB, hey, I'm about to tell you what my latitude limits are, and here I specify them. Now, you see how I put this variable named latlim? That's because in the code that I pulled it from, I had identified previously what latlim was. Another way to do it is you could just directly put in square brackets, and you put the value of your min latitude and the value of your max latitude. Right? So for example only, 35, 45, right? Or I could save that here. Yeah, I could save that there. Now, same idea. Now I tell MATLAB, all right, I told you the latitude limits, here are the long limits, map long limit, okay? And now I enter my longitude. Now, if I'm entering for New York, let's say, what's the longitude for New York City? Approximate.
So 40.
Oh, that's the latitude.
70?
73, let's say. East or west? 74 west. So how do I, so let's say I want to tell MATLAB to plot 70 to 75 west. What do I put here? And for my numbers, for my min and max, 70 and 75. West. What do I do? What numbers do I put? Is Paul right? Negative 70 and negative 75?
Yeah, because it's west.
Because it's west. All right, just testing. Okay. So negative 75, negative 70.
That's for the longitude.
Yes. How do I know that? Because I'm telling MATLAB what I'm putting here corresponds to the longitude.
What if you did it reverse? Does that make a difference?
Shouldn't.
Negative 70.
Shouldn't. Negative 75 is technically less than negative 70, right? So I'm putting the min and the max, right? Okay. Then I put the dot, dot, dot. Oh, why? Because that's just to go to the next line so you could actually see the rest of the code. Now I tell MATLAB, hey, I want to put a little frame on the image. And I say whether I want it on or off. Those are the potential choices there. Let's say on. Then I say, hey, I want you to add a grid. Should I turn it on or off? On. You get the idea? Now there's so many inputs you could have here. The best way to learn this really is to Google how other, different examples, because there's too many examples to really cover, okay? Meridian label, that's basically saying, do you want to label the meridian? On. Parallel label, do you want to label it? Yes, on. Get it? So it's basically setting up your axes that you want to plot.
Are these names that you're making? They can be whatever.
Hold on. I'm not making anything that's in purple is not made up. These are. Listen carefully, okay? This is telling MATLAB I want to choose my map projection. You have to put it in like this: map projection, comma. And now MATLAB has specified types of map projections, and you have to specify which type. Okay? Okay? If you want to learn more details about it, what do? Help axes M in your command window, or you look at the MATLAB documentation. I don't even memorize all this. Okay? Whenever I want to do a map plot, sometimes I just Google the syntax and I say okay, and I just paste it in. So you're not expected to memorize the order or anything like that. Okay? But does it make sense in general? The main thing is that I have to create my map axes and then specify the window and whether I want labels or not. Okay, so let's go here. Okay. So you know what? Let me just show you an example. I have some written code here. I'm just going to run it. There we go. And I told it to just plot 5 figures. Okay? With a for loop going from 1 through 5. Okay? So the first 5 files I just plotted. Let's just zoom in on 1. Okay? That's what I would get with the code that I have underlying this, which I'm going to show you. Okay? So you can see I put as the title, the file name. I chose to add a color bar. I have my labels. Here's the frame on, the dark black line, and my grid. Okay? And I labeled color bar. So all these things you need to specify. So, try it. Here's the code. I identify first, well, first things first, okay? There happens to be some data in MATLAB called coast, right? So what does that give you? It gives you all the coastlines of the whole world. It's just like inside of MATLAB, so I could load that. So here I load the coastline data from MATLAB, and that'll give me the latitude and longitude values for the coastlines. Can everyone see this? No? Yes? No? Who says no? You say no, I'll make it larger. Okay, so start writing it into your codes. Make a new section in the code that you have now. Right now I don't care about being as efficient as possible because we have limited time to actually do this. So there's always going to be a more efficient way of doing it, but to make it easier, to get it done, just put this in the same script that you have like now. That way you'll be able to do one of the deliverables with no problem. You should be typing it into your code now.
So we're gonna copy this.
Okay.
No, you don't have it. You have to rewrite it.
The for loop, start with k equals 1 through 1. Just leave it. Don't use the for loop yet, all right?
What are these?
Oh, the last one that we did. Yeah. The last one that we did.
How can I control this?
That's the direction. Does the coast.mat need to be downloaded, or is it already in your MATLAB?
Coast.mat is just inside MATLAB. Just write the code down and try each line, and then I'm going to explain it to you, okay? I just want you to get it down.
Okay.
We lost a lot of time, so, you know.
That's long. The long underscore mat. That's what we did before.
That's what I'm trying to do.
We're making a
What's that?
the long underscore mat underscore mat.
Oh, okay. Yeah, good point. Good point. Listen up, guys.
I need something.
This right here, these guys, these variable names are my variable names for my final latitude and longitude matrices. If yours are different, enter your variable name for the latitude and longitude final matrices. That means the three-dimensional ones that has all the data for all 606 files. Okay? Use your own names.
Yeah.
They're the ones that are 203 by 135 by 608.
Yep.
Use my cup.
Anything that's underlined, use your own names. Don't use my names, otherwise you get an error. And don't forget, for the for loop, just do it with 1. From k equals 1 through 1. Alright? And then we'll change it. Mayumi,
Yes.
can you check this out? So I'm sharing my screen from here. Alright. Yeah. Okay, sorry guys. Okay, let's just, I guess this one. That's better. Is that better, guys?
Yeah.
No.
If you could raise it up a little bit.
Does that work?
Can you elevate the whole panel on tiny bit more? Can you share this on the drive? Not scroll, but like the whole thing on.
Yeah, you know, it's kind of tricky. So I'm sharing this from my laptop. Okay, I'm assuming people got the first couple of lines. So I'm going to scroll down a little bit. Here, I'll keep the Latin and long. Now notice I have some commented lines. Copy those too, but make sure you have them as comments. I could just upload this code to the drive, but then you're not going to type it in physically. I want you to type it in physically and have some recognition of what you're putting in there. Is it the same function? If you save your function in more than one place,
yeah, I
make sure the location's right.
Yeah, I saved it. I put it in my Google Drive. I
So it's like a
the entire thing.
function works. Let's copy the time.
Yes.
You ran this right?
Yeah.
Pretty well functioned. Yeah. Where is it? Oh, this one. I don't see what you call it.
But never.
No, you did. Maybe. This is the original script. This is not the script what we did for every file. I don't see a voice.
Oh no, the final is where
Okay.
every
So, did you run it?
yeah, but it gives me this error.
Yeah. You have nothing. Look at this. It's on a comment.
But is there a reason? Is there a reason why
Let's, well, first of all, that
yeah.
is probably definitely an error. So that could just be giving you an incorrect error message. So let's see.
No, he lost it. I think I got it.
The final script is not in. You would have to, if you did it like this, you would have to tell it in your script to change directory to the right directories. So take this code and put it in the right folder. There it is. Download session name.
No, not all.
Yeah.
Oh, that's in the.
But is it in? Oh, well then we have to open the record. So let's put that out. Now this is in the right location.
Yeah, that is my reason.
Okay, that works. You're smart. Something's displayed here.
Even though.
Well, I mean, it's not part of the code. I'm just showing you guys how to still create Okay, and I scroll down.
So you didn't know what you
on this board. What's the question?
Do you mind just small characters? Sometimes long
Close the parentheses.
Yes.
See the red line?
Yeah.
That's how you know you missed it.
No.
1 second. Let me just hit
Yeah. 3 dots. And the K has single quotes.
No, but I think
Right, single quotes. Okay, now can I go over, can I start explaining the code to you guys?
not yet, not yet.
I'm still typing.
Look, you gotta bear with me guys, because we had a delay and there's a lot to do, so I'm sorry for the lack of continuity here, but trying. So, was there a question? No, so let's do this. First line. I started a for loop. Why? Because I'm going to span through a number of files that I want to plot. Okay? This line. Matlab has coastline data. I want to add that to my workspace. Okay, it gives me, when I run this, what do I get? I get this. I get a structure with 2 fields, lat and long fields. Remember how I call a field? If it's a structure, I call the name of the structure, which in this case is coast, and I put a dot, and then I put the name of the field. One field is called lat. The other one is called long. That's why you see it later in the code. Okay?
Does that come from the code?
Remember the file name list that we made? It was a structure, right? And then to get the file names, I had to put file list.name. Same idea. I named the structure coast. The MATLAB saves the latitude and longitude data in the coast structure. And then it has 2 fields, the latitude field and the longitude field. So how do I call it? I just put a dot after the variable name and put the name of the field. Coast.lat, coast.long.
Question.
Yes, question.
The coast.mat is already integrated into the MATLAB.
Yes. Coast.mat, this is a mat file that's in MATLAB. It's just part of MATLAB. It was nice of them to do that. Now we have the coastlines for the whole world. So basically, if I didn't do this, and I plot my data, I'm just going to see like a white space, and then just the data plotted over an empty space. So if I want to actually see the coastlines of like the US, that's what I'm doing here with the coast, okay? So that's what that line does. It gives me the latitude and longitude, which I'm going to use later. Here, on the next line, line 59, I chose to get the minimum for my longitude range, the minimum longitude out of all the files. So if any of the files had some shift in coordinates, you know, if it wasn't perfectly aligned between every file, I want to get the minimum so that every picture has the same constant window, that it doesn't change, right? So I get the minimum longitude out of every single file I have. And notice I did it with the colon operator. And I say floor, remember that's rounding down. And here I say ceiling, which is always rounding up. And I get the maximum longitude. So min and max longitude.
So would you have to know that all of the files have around the same minimum?
That's the thing. If some of the files will have different mins and maxes. So what I'm doing is I'm with this command right here, with this one line right here, MATLAB's going to give me the minimum longitude of all the files. And here, this is going to give me the maximum longitude of all
So
the
if
files.
one of the files has the least,
Exactly. So that way I have a constant window between every plot. It doesn't move around. And the same exact idea with our, let me shift it over, with our latitude. So it's very easy. In other words, if you look at the comment I'm about to write, I give the min and max in square brackets. Okay, so I didn't need to use this function floor or this min. I could have just put a number here. And I could have just put a number here. Okay? As long as the min and the max, the range. Simple, right? Kind of, sort of. Okay, now I say MATLAB, open up a figure, and I give it an index. Why? Because I'm basically going to say, all right, if I'm running a for loop, and I'm starting at k equals 1, I'm saying, okay, this is going to be figure 1. The next step in the loop, it's going to be figure 2. Okay, so that it doesn't get rid of my previous figure. I keep all my figures. So that's what that does. Now here, we kind of covered this. I put in my axes m function, and I specify all those parameters that I talked about before. Okay, let me just make sure nothing's left out. Did everyone get this dot, dot, dot on the end here?
Yes.
Yeah.
Again, the reason there's a dot, dot, 3 dots to be specific, you do that when you want to jump to the next line and tell MATLAB you're continuing the previous line. If I don't have that, I'll get an error. So that's what these 3 dots do. I'm letting MATLAB know I'm going to the next line, let's continue. It's not a separate line.
2 dots doesn't do the same thing.
2 dots does not mean the same thing. 3 dots is the same as 3 dots.
You have to put a shot. You also have to put a space.
Yes, okay, so if I don't put a space, will it work? Looks like it worked. If it didn't work, for example, if I put 2 dots, what's MATLAB going to do? It's going to underline everything in red. Say, what are you doing? It's not right. Fix it. You have an error. Then you look at it and say, oh, I need 3 dots. And now it goes away. Okay?
Yes.
Now, next line. Wait, let me just put a comment here, which is create my map axes. Okay, but one more thing I want to tell you about that I haven't really spoke about. Before I showed you how to create your map axes, right? Guys, listen real quick. I showed you how to create the map axes, but here I set it equal to h. Why did I do that? It's called a figure handle, okay? If I set this whole function equal to some variable name, that variable name is like how I can call it again. So later on, if I want to tell MATLAB, hey, remember that figure, those axes that correspond to h? I want you to change something with that. I want to change the font size. I want to add a title, right?
Oh yeah.
So by assigning it, in this case I say h, you can call whatever you want. My axes, okay? It's a figure handle or axes handle. And what that means is that later on I could call it again. Did I even do that? Oh yeah, I do later. Okay, we'll get into that. But basically, if I wanted to plot all this and save, let's say I want to save the figure, I would use some function that tells MATLAB I want to save a file, and then I have to tell it which figure. And I say, oh, figure H. Make sense? It needs to know which figure to take, right? We'll get to it. We'll get to it. Okay. Next line. Now, keep in mind there are multiple ways you can plot the data on a map. This is one way. Surf-M. Now, if you wanted to read more about Surf-M, what would you do? Help, Surf-M. And you could look to see alternative ways to enter inputs and all of that. Okay, but essentially, it builds a service on a data grid for you. That's what it does. project geolocated data grid on map axes. And to use this function, before you can use it, you need to use axes M. If you try to use this before using axes M, you'll get an error. Okay? Now, what's the next thing I do? So hold up. Let me show you something. I'm gonna run this, let's say from k equals 1. I'm just gonna run the first up to the point that we covered so far, up to surf M. Let's see what I get. Evaluate selection. Okay, so I get that. Oh no, that's an old figure. Let me close all. Did I close all? No, I didn't. Close all, that'll close all the figures I have, so I can start fresh with the figures. I'm going to run it again, just up to the line that we just covered, up to surf M. Let's see what I get. That's what I get. That's what I get. You see that? I have no coastlines, I got nothing. It looks terrible. So, well, alright, it doesn't look terrible, but now, that's where the next line comes in. Now I'm telling MATLAB, hey, use this plot M function. Plot M is the plot on a map. And what am I going to plot? The latitude points from coast and the longitude points from coast. And again, why do I put coast dot lat? Because coast is a structure. And to call the field that has the data, you have to put dot and then the field name. Make sense? Just like we did with the file list. File list, dot name. Here I'm doing coast dot lat. Coast dot long. This will give MATLAB the latitude values for all coastlines and the corresponding longitude values for all coastlines. And then what the K is for in the single quotes means I'm setting the line to be black. Okay, I can choose a different color. It can be red, which would be R. Yeah?
Mine says unable to find coast data.
Okay. It probably has something to do with your version of MATLAB then. So, unable to find coast.m?
Yeah, that's right.
Yes, there's no such
Okay.
file for the record.
Okay. Depending on the version you have, you might have trouble with coast. Try this. Do you get an error when you say load space coast? That should work. If it doesn't, then I don't know. It's definitely with some change attributed to the version you have. Because MATLAB, they get rid of stuff, they add stuff, they change stuff, okay? If you don't have it, don't worry, that's not a major issue. But if you don't have it, just comment out the lines that refer to coast, okay? We'll live without it for now until we find a solution. Okay, so if you do have coast embedded in your MATLAB, running this line will plot the coastlines. So again, here's the figure without the coastlines. I run this line, and it puts the coastline. See the difference?
Did you set your lat and long lives from before?
Did I set my lat and long from before?
Remember how you did long lives, -75, -70? Or did the seal and...
No. That was, remember, that was just an example for the time being.
So the seal and floor take care of that?
My limits, my latitude and longitude limits are defined by the minimum and max, global minimum and max across all 608 files, 606 files. Okay. Next thing, I add a color bar. Simply typing in color bar will make a color bar pop up. However, I assign it to a variable name, C bar in this case, again, any name you want. That's the handle for the bar. Why do I want a handle? It's basically so I can call it again if I want to modify it. If I say, hey MATLAB, I want to change something with that color bar, I just refer to C bar now, okay?
The color bar is the blue mask that you have, right?
Okay, let's see what the color bar is. The color bar, when I run this,
Oh, I got it.
okay, what's the color bar? But notice the colors, look at the colors of the color bar. Okay, that's why I specify color map, and I tell MATLAB, hey, I want you to change the color range, I want it to be jet. And when I do jet, again, you could Google these like color bar, color map, and there are different color options. I prefer to go with jet. I run that, and see how the color shifts? It goes from blue to red, which I personally prefer. Okay. And now I can add a title to the color bar. See that? And how does MATLAB know to add the title there? Because I said, oh, add it to C bar. It knows that the C bar corresponds to the color bar. Okay? If I don't do that, like in this example, I'm titling the whole figure. So I need to be able, if I want to title something else that's within the figure, I need to be able to point to that. So MATLAB knows. Yeah?
Real quick, you also put, instead of color map jet, you put C bar jet?
No, color map is like the actual command, the function. Okay?
So you have to correct.
Yeah, it's a separate thing.
Color. Or color bar.
Yeah.
Oh, I see.
It's color bar, then color map, if you want to specify the color variation. Okay? So this adds a color bar. Changes color scale. Okay? This adds this line here, line 74, adds title to color bar. And now, to title the figure, I didn't show you this, but this is a nice little approach here. Now, what if, let's just say I had like a supercomputer and I had no issue with running a for loop through all 600 files and plotting every map for like 600 maps, okay? And I want to put a different title to each one. Now, do you really want to type in manually a title for each one? No, right? So how can I do that? Yes.
So you do with K, right? Parameter K.
So let's see. Let's look at this line right here.
Display.
Hold on. Let me scroll down. This line right, this line right here. Okay? Line 78. This is important. I use it a lot. Okay? Now, if I wanted to manually add a title to any plot, any figure, I would just say title, but okay, whatever. I would just write title and then put in single quotes what I want the title to be. Right? Here, I'm using this function called sprintf. Okay? And what that allows me to do is I can write in, within single quotes, I type in the part that's never going to change. So every title is going to say file, colon, and then the file name, but the file name is going to be changing, right? So how do I do that? When you use sprintf, whenever you put in a percentage sign, followed by some symbol, some conversion character, MATLAB knows, like, when you put that percentage sign there within sprintf, it knows, like, okay, what character is he going to put after? I put an S. What does that mean? String. The only way you know this is if you look at the help documentation for the function. It tells you. If you put percentage sign S, and then you put a comma after that string there,
That's going to turn into a string.
this is the variable that's going to be replace that percentage sign S. So one more time. I know if you've never heard of it, it's tricky. But basically, can I don't think I can use the board. Okay. Basically, this variable, file list dot name, the for loop is being used to index this, right? So K is changing. So I'm going through every file name one at a time. So basically, by putting this percentage S, that basically tells MATLAB, take the file name and put it there. Okay? If I wanted to put a number there that's going to change, okay? Let's say it's the average AOD. I don't know, I'll make something up. You have to put a different character that symbolizes a number will be there. Here's D for, I believe, double. And then I would put something like, you know, max of AOD or whatever. Okay?
So you can't do it like the traditional way of doing file, colon, and then the name of it? It's
Okay.
a string, or is that?
Okay, check it out. If I was just doing one file, here's what I would do. I'd say title, that's the function. In single quotes, I say, all right, whatever I want to say. My first file. Close quotes, close parentheses. But what if you want to have a dynamic name, something that's changing hundreds of times? You're not going to type it.
Yeah.
So, let me show you in the command window what sprintf does. Okay, sprintf. Now, inside the single quotes, I can say whatever I want. Adam is the man with the plan, and then I would put in something that's going to change with every step in the for loop. What's going to change in this case? The file name, right? It's always changing. It's like, you remember that long Lotus file name that we talked about? And I don't want to type that in every time. And what is the file name? Is it a number or a string?
It's a string.
It's a string. So I can say %sign. That's how MATLAB knows, he's going to have something that's going to pop in place of this, and it's going to change every time. And then because it's a string, it just so happens S, let's map %sign S, let's map MATLAB know, you're going to put a string there. That's it. Now I close the quotes, and then I say file list, which we identified in our code yesterday, we defined in our code yesterday. Now put k.name.
Did you say that if it was a matrix, you do D for
See
double?
that? See that? I didn't have to write that out. This is saved in this variable. And it takes that variable that's saved and pops it into place for this. If I have multiple conversion, let's call this a conversion character. If we have multiple of these, then it would do it by order. For example, if I had another file name, let's say I wanted to say, okay. What if I wanted to put two file names for whatever reason? Okay? File 1 equals, and then it's going to be whatever that file name is, and file 2 equals %sign. Okay, so now I have two. MATLAB sees two of these, so it's going to expect two variables to follow. And it's going to take the first variable and put it in the first one, and then the second one you list will be in the second. So let's just say I did whatever. Let me do file list k+1. That name. See what it does? Two different names, and I didn't have to type them in. Does it make sense, guys?
Yes.
Okay, good. Again, if it's not clear to you, help sprintf or .sprintf, and Google it, and you'll see examples and all that. All right. So basically, that's what this line does here. It allows me to have a dynamic title for every file name. This one just gives me a white background. Now, if I want to save the figure, okay, let's say I want to save it as a JPEG. I like to do it as a PNG. I save it as a PNG, and then you want to put it in a Word doc. Let's, if I uncomment this line right here. Oh, wait, before I do that, let's look at the figure, okay? What's happening here? Oh, wait. Hold on. Close all. I changed something. What did I change? Oh, see what I did? I changed the conversion character was an S before, telling MATLAB this would be a string. I changed it to D, which is now telling it it's a number. So we don't want that. S. Okay. There it goes. Now, the problem is, before I maximize the image, notice how the color bar title is overlapping with the title? I mean, yeah, so when you save this as an image, it's going to save like that. If you don't want that, you need to figure out a way to change the position of your title for the color bar. So, I have it there for you, and there are many alternatives to how you could write this in, but, so here, this line right here that says title, C bar, AOD at 550 nanometers, comment that out. And open up the line right below it. cbar.label.string equals that. This is going to give us a vertical label on the side of the color bar. Okay? Now again, these things, you just look them up. There's no way you're going to memorize all these things, alright? So, now if I run it, my new figures don't interfere with the title. Check it out. It's on the side. Yeah? Okay. That's it. That's how you map it. That's one objective that you would need to submit. Okay? Now let's get into the real work. I told you that there were 3 objectives, right? I spent a lot of time on it. Scatter plot, time series, and mapping the AOD data. We just mapped the AOD data with this. I gave you the code for it. So let's see if you actually did. One more step actually that I forgot, to save the figure. Now we want to save the figure. You see this last line here? Save as. So remember I told you that I set axes M equals to H, right? So that I could call those axes again when I want to tell MATLAB to do something with it. Here's where I'm going to use it. I'm going to say, hey, MATLAB, remember I told you the figure, I'm going to call it H? MATLAB's like, yeah. All right, well, I want to save that. So I use this function called save as. I specify I want to save that figure, those axes. And then, in single quotes, I put my name of the figure. Now, if I wanted a dynamic name for the figure, how could I do that? As Printf. Okay? Just like I did here. So I could even take this, put it there. Okay? Or you could just say whatever, my AOD map. Whatever you want to call it, just the name, followed by the extension. If it's a JPEG, it would be JPG. I think PNGs come out looking better. The color just looks better, you know, when it comes out of MATLAB. So I use PNG. All right? And that's how I would save it. I run that. Now, since I'm running a for loop from 1 to 5, I didn't have it save each one. It's only going to save, it's going to save over. It's only going to save the last picture, okay? I don't expect you guys to plot multiple maps and do this. Just give me one, okay? You save and you use the code to do it, and once you save that image, you can put it in the Word doc. Okay, so everyone's clear on that? Should work. If it doesn't work,
You see a blank screen.
the 2 choices. You made a mistake.
Everyone's getting a blank screen for the map.
Getting blank.
Yeah.
Yep.
Yeah, I get that.
If you're getting a blank screen for your map,
Is it because of the code?
you saw it worked on mine, right?
Yeah, but ours doesn't, code doesn't work on ours.
Okay. Okay. What if you say load coast? Load coast and then and check your workspace for long and lat in lowercase. And it should be, the only problem that can arise here is if you named your final latitude and longitude matrices the same name. If you just do load space coast, it should load. Which that has to do with you put your longitude as your latitude, and your latitude is your longitude. That's what happened. Okay. Check your code carefully. Guys, a lot of you say, hey, it's not working. You got to check it carefully. All right. Okay, let me go to the first person who said coast wasn't working. Let's see. Yeah. Okay. Then you'd have to do it on the desktop. Check it out, guys. All right, here's another issue. There are other, so MATLAB has all these toolboxes, a billion toolboxes to do all kinds of things. Machine learning, optimization, mapping. If you don't have the mapping toolbox, you're going to be a little screwed. Because it's missing some of the essential functions we need for mapping things out.
How can we check if is there like a load function?
Well, his gave him a message that says you're missing the mapping toolbox. I just assumed we all had the full version.
So we can import it, right?
Where do you
import from?
If you go on your command window and
You can try
it says M and it says you need the mapping toolbox, you don't have it.
Your desktops should all have the mapping toolbox for sure. Okay? Your personal computer might not.
If
Your desktops will definitely.
If the mapping toolbox didn't work, our box won't show up as blank.
Do you get an error? You gotta look at the error message. What does it say?
I got everything right.
Error in access.
No.
Just when the box is open.
I got
You got it. Good.
Error in access.
Yeah. So I tried to correct the error, like I said. My error was
It's telling you error in axis M. You gotta go
this
to your
one.
axis
I
M line.
put
See what
lower cases. It should be capital.
Let's find out.
And then try.
See when you're trying to
I still get in two different.
You can download it, you just can't do it here for Wi-Fi.
Maybe this one is one.
Yeah. But required, that's if you're required.
Look, it's this one. Mine is a little bit different.
I'll take care of that.
Take care of
Recognize proper name. Matt Longland versus Matt.
Yeah.
So change your map long to map long.
Yeah, go back here now.
Yeah, Matt Longland. Matt Longland. Remember I said it has to be exactly the same.
Well, this is what it looks like. That's something.
What kind of projection do you have? Okay, listen, you got it. Guys, if it's not working, you know, unlike the other days where I came around and helped you until you got it working, you're gonna have to keep playing with it until it does. Because we got other stuff we have to do. Okay? Yeah, let's do that. The save as line.
It says post mask and not in the directory. Because my laptop.
You could probably just download the Coast math file, right? Let's see. Let's check real quick. Download Coastlines Matlab. No. Coast.math, alright? In case a lot of people are having this issue, let's.
Try again. Well, on the link, it just got
Okay, you know what? You can see what you can find online. I recommend using desktop if you're having issues. Okay? But look, this is, to me, this is not the most important thing. This is not the most important thing. The most important thing is the scatter plot. Tomorrow.
So if I don't code and then you download the box when I get home.
But there's one thing.
And check it out. For whatever reason, I prefer if you could get the coastlines in there. If you can't get the coastlines, at least the plot without the coastlines, it's something, right? So it's not your fault if your personal computer doesn't have it and you can't get it. Guys, pay attention real quick. We're gonna jump to the next mission, all right?
Okay.
Our next mission is we have to match the location in our AOD data. We have to, for every file, we have to find the pixel that corresponds to the station location for AeroNet, CCNY station location. So number one, what do we need? We need to go online and find the exact coordinates of CCNY, the AeroNet station at CCNY. Latitude and longitude, it's pretty simple. Look it up. Those are going to be constants. So, here's what I'm going to do. I'm going to start under this section that we just did. We're going to make a new section. Match location. Match modus location with CCNY station. I got it. AeroNet station. For every file. Okay. So you can say something like CCNY lat equals, and then look it up and put the number there. CCNY long equals, look it up, put it in there. Okay. Now, what I would do is I would go to the AeroNet site. AeroNet, NASA.
It's 40.83 north and 70.
Okay. But I want people to get into the habit of having to find it and put it in. Okay. So I can go here. I have all these stations.
What did you click on that station?
CCNY right there. Remember, west, if you have a west longitude, it's got to be negative. Guys, we're moving on to something that's much harder. Well, it's not really hard, but it might be harder for you if it's your first time doing it.
On the main page,
Where was?
you said, when you get to that first arrow net.
Yeah, click on that picture of the map where it shows all the site, just click it and it'll take you to this. So I'll go one step back. I went to the AeroNet page, I just Google AeroNet, NASA, I click on the link, I go here, see that? I clicked on the map, just click on the map.
I think it's frozen. The projection is frozen.
Oh, no, it's just lagged.
Okay, so what was the first?
Arrow, okay, I'll do it slowly. Type in AeroNet NASA. Go to the first link. Okay?
Oh, that's the second.
Sorry for the lag, guys. Now, I go to the map, I click it. Now I can scroll down. Wow, this is slow. And go to CCNY, and I can just copy the coordinates there. Key point: do not for your longitude. It has to be negative. If you don't put a negative, you're going to get completely wrong coordinates. Can we all see that?
Yeah.
Sharing that.
Next to.
Change that to this computer. Okay, so here, who has an idea of what to do?
Fine.
Let's take one, you gotta think and plan this out. Think of one file at a time before you think of doing it all in one shot. First you say, I know my MODIS data is a matrix. It's really a map of a whole area. As we saw, we plotted it. Some of us did, or you saw me plot it, okay? So we know we're dealing with the whole area, and we know somewhere in this matrix, one of the pixels is closest to the CCNY station. Let's say it's this pixel. That happens to be where CCNY is. I need to know how to find that index. Either that index, which is just the single value, or the sub-index, which is the row and the column. Row, column. And guess what? The row and column index is going to change for each file. Now, so like I said, let's think of one file at a time, okay? We have, what do we have? We have latitude, and we have longitude. Let's think of those like X and Y, right? So what if this is X? What if this is Y? Okay? And what if I have a point?
It's the layer.
And let's say I'm scanning through, I'm using a for loop to scan through the image, right? So my for loop is scanning through this graph. Now let's just pick any point in the for loop. I stop the for loop, boom, pop. It stops here, right? How would I determine how close this pixel is to that pixel? X and Y, right? Distance formula.
Yes.
Now there are different ways to do it. Simple way to do it is the distance formula. Not the only way. Not necessarily the most accurate. If you want to get the actual distance, because the actual, well, the more accurate estimate of the distance would not be the distance formula, because that's for Cartesian coordinates, X and Y. Whereas on the globe, it's spherical, right? So it's there's a different distance formula for that, Haversine, right? We don't need to go that far. We just need to know for every pixel, right? So imagine how I drew out all the pixels. I'm going to calculate the distance between this pixel and that pixel. Calculate the distance, calculate for everything. And then I take the one that has the minimum distance. And the minimum distance pixel should be the one that's closest to that point.
Are these?
Now think of latitude and longitude as your x and y. It doesn't even matter which order, because in the distance formula, what is the distance formula?
Equal to square root of x, parentheses x2, take away x1 squared plus y2, take away y2 squared.
Okay, so, and does it matter which order? Can I do x1 minus x2?
Yeah.
Yes,
It's squared.
because it's squared. And then,
Plus
Y.
y2 plus y squared.
this is all in the square root. I'm sure all of you know this, or you learned it at some point. Okay. So, what are we calculating the distance between again?
The long and lat.
The
2 pixels.
Pixel 2 point.
Yes, but which,
The pixel in the file and the pixel from AeroNet's data.
an AeroNet's pixel, does that location change?
Yeah.
No, never changes.
Wait,
That's
you
like
said
saying
it's-
City College moves on any time of the
You
day.
said it's spanning.
The satellite is, right?
Okay. Oh, but when it goes over City College, it's always the same position.
Okay, so let's think about this. I have one location that's fixed, City College. That's where our AeroNet station is. They have some instrument on the rooftop somewhere. I don't know which building, we could go find it, okay? So, it's fixed, never moves, it has constant coordinates, right? If you put some wheels on it and pushed it down a hill, then you'd have changing coordinates, but you don't have that, it's fixed. Therefore, my x and y are the same. Now we're only interested in calculating the distance between that fixed point and every other point. So the distance between this point and that pixel, between this point and that, this one and that. So let's just say, for this formula, let's say x2, this point is x2, y2.
What do those other pixels represent? Like, they're not part of the AeroNet data? Are they part of the?
What's the first layer? Pick any layer in your latitude and longitude, your final modus matrices, right?
Yeah.
That's what those pixels are.
But
Those
they're-
matrices,
But they're lat and longitude values, though.
okay, one step at a time. Let's say my x2 and my y2 correspond to my latitude and longitude, okay, for CC and y. What is the other one? Our other x and y coordinates.
Latitude and longitude of the modus line.
Okay.
Added points depending on.
I'm just gonna tell you straight up, okay? Give you the straight. Okay, check it out. What's my, for any given file for modus, let's just say I have AOD lat. It's a whole matrix, right? For one file at a time, okay? Let's say I have my AOD long, and this, again, is referring to the modus data, okay? Maybe I should have put modus, not AOD. Whatever, just follow me. This is a whole matrix. Lat is a whole box of values. So is that. Long is a whole box of values. All right?
That repeats.
All right, whole box. CC and Y, is that an array of values? For just a longitude. It's scalar. So I have a single point, single element, distance formula, x2 minus x1. These are all our x1s. What happens when I take a scalar and subtract the matrix?
It's gonna give you an error, right? Because of the,
No, it won't give you an error. Yeah. Okay, let me just, maybe it makes more sense this way. What if I multiply this whole array of values by 2? What would happen?
They would all double?
Each value will double. Yes. Yes. If I add 2 to this matrix, what happens to all the values in the matrix?
Each one would
It adds 2 to them. So the same thing, right? This is like, I could easily just write this the other way. I say lat minus CCNY lat. And it would subtract that fixed value from every value. So you don't need a for loop to go through every one. So there's a shortcut there.
Remember when you opened up the file yesterday for the longitude and latitudes? It was like, it was either one column value that repeated, or it was all of the rows that repeated. Is it the same thing?
That's latitude and longitude.
So in this case, would it be like wasting like time by doing each one? Could we do like one from each like new column?
If you want to make it harder for yourself. Yeah.
No, but it's gonna take like 10 times longer, doesn't it? to
It's
run?
probably more efficient. It would be, if you could do it where lat is a vector and lon is a vector. But guess what? Lon, I said it was almost constant for longitude, vertically,
Oh, it's not.
but it's not exact.
Oh, okay.
You're better off doing this.
Okay.
Okay, so distance formula. x2, now I'm just giving it to you guys. My x1 is a whole matrix. When I do the subtraction here, it's going to result as a matrix with that value, you know, this minus that, replacing all the values. So it'll be an array. I can square that array, dot square, right? The dot before the raised into the power. Plus CCNY long minus that squared, dot squared. We're doing element by element operation. And then the whole thing, square root. Yeah, you'll have to connect that. Easy, right? Yeah. Scalar value minus the array, you're left with an array squared plus scalar value minus an array squared. So now your distance, after you do the square root and that whole thing, will just be a matrix. Matrix D. And inside that matrix are all my distance values with respect to CCNY. And I would just want to find the minimum value of that whole matrix.
Wait, Professor,
So go ahead. There it is.
for the first one, should I stop it in the same index? Where should I stop it? When I do the difference square, where should I stop it? In the same index? Where should I store it? In the same index?
You have to think about it.
This one,
Wait 1 second.
We can just live off the
So did this explanation make sense?
Yeah.
So we have to take the negative values.
Alright.
It's like 80%.
Yeah. So I downloaded the data with the same timeline that matches the timeline I followed. So you don't have to do this. If you wanted to, yeah. What's your question about the Oh no, the longitude. Because west is east and west. So positive 73 would be on the other side of the world. Positive 73. And then west would signify negative 73. If you don't get negative 73, Matlab Training, the coordinates on the other side of the world. Just go on Google Maps, latitude, positive 73, and see where you end up. And not where you want to be. Okay, did you get that? Okay.
In their last piece.
Washing machine.
That's very bad. Followed by the very beginning, and then you close the play. Comma, file name, that's the very name. And now it's.
Hey, it's not gonna help. Hit it. Get hurt.
Yeah.
Unable to read file post, no such problem.
Actually, no.
Okay, so just comment out the post stuff. That should have been applied.
If it fails, it fails.
I really suggest make a new section.
Would you mind the
Guys, I hope you can do this relatively quickly because there's still other stuff. After we match the location, now we have to extract all the times from the modus files. Okay? And we have to also read our ARRowNet data now, extract that data, get those times, and then match the ARRowNet and modus times. So now we're just doing location. Then we have to match the times. And we have to interpolate the ARRowNet data, because guess what? They don't give you the 550, AOD 550. They give you something like AOD 470 and AOD 660, and you have to interpolate between the two. So, let's try to do this with some sense of urgency.
The latitude you said was 70, right?
The data?
I mean, the latitude, right?
You could you could look up the latitude, right?
It's minus 7.
Mohammed, weren't you following me when I went to the ARRowNet site and I did it like 10 times?
No, I have it right here. I'm saying which one is, because I'm saying X and Y.
X,
I want to make sure
lat, long.
It's lat long. Okay.
Okay. Y is more like lat, but it doesn't matter as long as you're subtracting lat from lat
Yeah, that's what
and log from log. That's all. It doesn't matter the order. What was your question?
I don't know what we're gonna say. Beat that
Yeah.
kind of stuff.
Matching the location.
Yeah.
Yeah.
Because I don't see any such thing.
I gave you the equation, so you literally just have to translate this equation into MATLAB syntax. And then you need to know how to pull the minimum distance from each distance matrix that you have.
No,
You did the wrong line.
instead of that, it should be the whole thing.
You should use this number.
Yeah. Then you should do the same.
What I would suggest is after you get this equation, after you type this equation in and you test it for one file, so saying all the rows, all the columns of layer 1 for lat and long, the modus lat and long, see what your output is. Just run the one line and see what your output is, right? Before moving ahead. Then you have to think, how can I take the minimum, find the minimum value and its location in that matrix. It sounds more excruciating than it really is. Okay? How are we doing, everyone?
Getting there?
Getting there? How many people got this equation into the script? You literally just have to know how to write square root. And aha.
Do we need to keep the north and the west?
Hold on. So what should your result be? Once you run this equation for the one file, what are you getting? You're getting, what's the size of your result? 203, 135. So you're getting all the distance values for each pixel now with respect to the CC&Y location. And now you want to find, out of all those distance values, all those options, you want to find the minimum one. Not only the minimum value, what's more important to us is the actual location of that minimum, finding the index. I'll give you a hint on that. after you run this equation for one test file, the next line is going to be something like using the minimum function to calculate the min and find the position of that min. So how would I do it? You go to help min and see alternative ways of using the function. Remember how I said if you have more than one output, you specify more than one output for a function, there could be other outputs that are designed in these functions. So, go to help min and see how you could use the minimum function to find the location of the minimum. When I got the license, yeah. Definitely, I had the same problem originally.
We're just trying to explain.
Yeah.
This equation. Look at this.
You good? It's easier just to have as a variable, so we just write so that variable instead of
It says.
Remember the exercise we did, like it gives you the minimum function to by default. It gives you the minimum of every column, right? Where I get the middle. See, there's a reason why I taught all that stuff to you early in the beginning, because it all adds up. It's all like that.
What's up?
That's exactly what I'm going to do. Little guys there, little guys there. That could be good. Remember he said, it appears to be excruciating, but it's no good. They don't want to watch, bro. You know why? I'm not. Don't worry. England is going to make a comeback. England is going to make a comeback. Read that. They're going to make a comeback. You have to be
They took out
Sad.
Yeah.
No, they were only both.
Oh. Can I join you?
Come on.
That's not a lot.
It's common in this game.
Almost 200,000 people. They hit the most gases per person. Really? They're terrible. Cars. Per person. Why do they have the most cars per person? No, they emit greenhouse gases and kerosene. So you have to get cars. Because everything's just spread out. And they're very fortified. But now personally, they have efficiency laws, emission training.
Plus, actually, Cali is like pretty efficient.
California is the third most.
So you guys finish this part?
Should we have the distance and the?
Yeah. Finding the minimum distance location
Yeah.
for every file?
I came up with a matrix.
Forever.
Yeah, so you calculate the distance matrix, and you have a matrix of all these distance values,
Yeah.
and then you find the one that has the minimum value and where it is, what row and what column. So you have to record the index of every file that corresponds to, that's going to basically tell you, in this file, this is where the CC and Y pixel would be. In this file, this is where the CC and Y pixel is.
So mine, for the closest one, came up with a 1 by 135 matrix.
That's all the row numbers.
Yeah. It's one row, but it's just on the columns.
Yeah, so it's the min of each column, remember?
So you
And
don't
the
want-
index that you get from that is, so all right, you're gonna get the min values of every column by default, remember that?
Yeah. So you want, oh, okay, yeah.
So you have to find the actual location, the row and the column for each layer. And then you have to save them for each file. I'm just giving you something that you would actually have to do if you had to match satellite data with a fixed location. I mean, there are tools out there where you could skip over this in some cases, but
Maybe, Adam?
are you guys stuck or what's up? Okay.
Maybe I'm now on the track. I don't know. What I did is this.
You still
This
plotting
is
the
what I get.
maps? You still plot, those are imaginary numbers.
Yeah.
Oh, you're
This is
trying
what
to
I
do.
did.
Okay, square root. You didn't put, where's the squared?
This
You
one.
didn't do
Well, this is
squared, right?
Yeah, this is square root of everything from here. Without the parentheses.
This part squared.
Oh yeah, yeah. But
This part squared. If you don't do it square, it's going to be negative. It could be negative inside. That's why you get the imaginary.
yeah, I see.
If you have negatives inside a square root, you're going to get imaginary numbers.
We didn't necessarily need a formula.
This is a matrix, so the result will be a matrix squared. That's why one of them should be your matrix, right? And what is that? You gotta always look at the dimensions and ask yourself, what am I doing? Because you're gonna do 203 by one. You're gonna do for every file. You gotta do it one file at a time. One file at a time. How do you specify? No, this is for all 608 files. How do you choose for all the rows and the columns of the first file, all the rows and the columns of the second file, and so on? Forget about the figure and all that stuff. How do you say all the rows? Break it down. Then how do I specify all the columns? Then how do I specify one layer at a time? One. And if I added a quarter later, what do I change the one to? Yeah, if I say exactly. Exactly. So you should do that.
You gotta do for 1 to lengthify.
My point is,
One to lengthify.
three-dimensional matrix. You technically could do that. You could do that. You could do that.
No, latitude is the y-axis from left part, so it's right to south. Yeah, that's latitude.
Okay, look, if you do this, subtract by all of
Longitude
these.
is east-west.
You could do that.
You have the
You're
prime
gonna have to
meridian.
think of a way to extract the minimum value for every layer.
I'm sorry, longitude. Think of the longitude
That's
prime
actually,
meridian.
that
That's
would
up and
work.
down, so that's the x-axis.
Okay.
Okay. So the way you had it could work. The key is at the end, and you, for every matrix, for every distance matrix, for every layer,
Yeah.
can you find the minimum value, the location of the minimum value? Find the closest
So
pixel.
you have this, right? You have the line,
And that's the objective.
this is what?
And it has to be the minimum function. So go to help, min, and see other ways to use the minimum
Going along
function.
this one right away. You have 10 norths. That's going along the line. See what I'm saying? So you have 40 is over here. That's the name of 70 is over here.
Let's see.
Are we using the 3
Well, we're using the one that was in our
2D.
in our.
I just came back.
There's different ways to do it, guys. There's a bunch of ways to do it, okay?
And then I did it for you also. I didn't do the, I didn't index it to one. Yeah, so yeah.
I mean, you're using but those different
Edgar, what number did you get for minimum? I'll check.
Did you get 175.17 for the midpoint? Oh. I could be wrong. This is for one, but not for all of them. Oh, I don't know which one.
No, this is better. There you
Wait, you
got it here.
I got 132.
We have a function called a built function I call it the file. And it gives you data stored and see how value function. So the one this is more is this is one support
That's why.
So
For one? Did you get 175? Is this how you did it?
I'm just taking the word left computer science.
I did 4
I put this one.
the way it's
I
I put
You still did file.
They don't have it. I have it.
to the way find Excel.
I'm not sure. That's why
So guys, did you get it? Were you able to find the closest pixel for at least just the first file? Okay, how many people calculated the distance matrix for the first file? There's no reason you shouldn't have gotten this by now. Because I gave you the equation. You literally typed this equation in. Do you know how to type the equation in? So who hasn't typed the equation in and tested this for one file? Okay, except you. Who hasn't?
He's just asking.
I want to know how far everyone is. I would say that everyone should have been able to just
I type it, but I'm not
do
sure.
this for just the one file, for the first file.
I type it and I got a result. I don't know if it's correct or not.
Okay.
I
Don't worry about if it's correct. If you got a matrix result with 203 by 135, next step, see if you find the minimum and its location. That's the key, right?
I got the minimum that something was scratched.
Yeah, it was
Oh, it looks good now.
Yeah, but I got that's like really small.
Oh, you should have a new one before you take it off.
No, I just took it off because I don't like it.
Because you may like scratch it.
So, are you using the longitudinal latitude? He's like, I put it.
Oh yeah.
Yeah, so if you try the 3D, your result is going to be 3D, right?
I'm just gonna ask you. Because I
So
probably
it's possible that you could, there's probably an approach where you could get the 3D distance. Still, if you have the 3D version of this distance matrix, you have to be able to, from each layer, find the minimum location. Now, what we have here in this distance matrix is like the result of subtracting the coordinates of any given pixel in that layer with the CCY's coordinates. And you want the minimum distance to find the location. So it might be harder to do that if you're dealing with
What about all those
3D. Okay. I'm not saying it's impossible. I'm not saying it's less efficient. It might be more efficient in terms of comprehending it and getting it done in a timely manner.
But let's
Probably going to do it later. Okay, so if you do it with just this layer. Yeah, do it with just one. Equals 1, 3-dimensional. If you get it working for one layer, it'll work for the others. So now let's look at the, just to
That's the same
feel. Have all the distances. I want to find which position has the lowest distance. Now check out the help of the min function. See if there's a way.
So, I don't know how to find the value in order to know where the location is.
Yes, that's what I said. Look into that.
I put the distance formula inside of the mean to find out the mean. So I don't know. The first one I got, and then what did it?
Find the mean?
Yeah.
Oh, the min. Oh, wait, what's going on here? Let me see. No. Okay. Guys, again, take one file at a time. You have your latitude matrix. Let's just forget about the 600 files. Think one file. What do we have? We have a whole tile of the latitude coordinates. Those are all different points. Okay? We have another matrix for the longitude. Okay? It's because we have a whole area. Now we have the fixed location for CC and Y. That distance array, it's going to be a whole table of the distances between every corresponding element and that one fixed CC and Y location. So if we calculated all of the distances, all the possible distances for every pixel in that tile in relation to our CC and Y station, we want to find the one that gives us the smallest distance, the lowest, okay? The minimum distance. That pixel means that's the one that most closely matches our CC and Y location. And then we want to get that AOD value and compare only that one pixel value with our ARNet AOD. Right? We don't want to compare all of the AOD for the northeastern US with CC and Y. We just want that one pixel value. That's what all this is for. How can I find the location? There are a number of ways. Remember the find function? You might try using the find function. I would say use the minimum function. If you look at the help documentation like I told you to, you'll see there's an alternative where you could type in the minimum function and specify an output that will give you the index of the minimum. So you have to try that. It's tricky, but that's what it takes. So you should be, if you haven't looked at the minimum function, the other ways of putting it in, you should be doing that. Because if I just give it to you right now, what good does that do?
No point. So wait. Part theory is all part theory.
We're finding the closest pixel
To the middle,
not to the middle, to the ARNet station. Right?
CC and Y.
Yeah.
But if he wants us to find
So if you run this and you get something? Run it?
So how many people looked at the minimum function, the help section? So Barry, Nicole, you didn't look at the minimum document, did you, or did? I want to know who looked at it. What I'm saying is this. I'm saying type in the command window help min function. And look right here. Okay? See that? What does that say? Min-X returns the indices of the minimum values in this output I. Right?
Yes.
I mean,
See now.
I see now.
you might have to take another, it might not just be that line, but that's the start, right?
Okay, so this would be the final. So you would have to get 600 values.
That's the distance, which oh, this is of the whole 3D matrix. You realize that, right? This is not just one file. This is all 608 files, and you're finding the min distance of all of them, which basically just corresponds to one of the files, not the first file. Right. So if you you want to test it on one file first to get it working, you should specify the first file. Okay. Guys, remember with our class photo project, how do you specify the red layer? Colon, comma 1. How did we save our Modis data, all the files? The same way we had the layers in the RGB image. So if I want the first file, I say all the rows, all the columns, layer 1. That's the first file. We basically made a book of Modis data. For our first file in the year 2000, I said, hey, put all my matrices here. I want my latitude there, longitude, they're all separate. AOD there. Next layer, it's a book of our data. It's the same example, it's the same thing, right? So all the rows, all the columns, layer 1 should specify that you're working in the first file data, the data of the first file. So some of you are trying to do the distance matrix for the whole 3-dimensional matrix, which includes every file. So I'm not saying it can't be done, I'm just saying it's going to be it might be harder to conceptualize to find the minimum distance location in every layer. So do it one layer at a time, I would recommend starting off. And again, to get one layer, you call it colon, layer 1. You guys know how to do that. You're getting an imaginary complex number, which means you didn't square something right. Yeah. See that? Parentheses, and then you're going to close parentheses. This closed parentheses is just for the flat tab because it's specified. It's probably the same thing for the same. Don't worry guys, the first time I did this, I was very confused actually, and it took me a while to get it. Okay?
And you have a textbook that walks you through these things?
I actually learned this. Sometimes the best way to learn how to do this stuff is from someone else's code. Okay? So I learned from one of the PhD students when I was an undergrad, and I just built on that. But I actually found that a lot of that code, like I was doing it that way, and as I got to learn MATLAB more and more, I realized, you know, there were like triple for loops in there, and then I realized how to do it without any for loop. So sometimes it's good to just like work on your own, but sometimes you need to see examples, right? I'm trying to get you guys to get used to doing things on your own, because guess what? This is all fun. We're all in a big group now, but when you go with your mentors, it's not going to be a big pack like this, right? You won't have the same chance to work with others as much. You might be on your own, so you need to be able to dig yourself out of a hole. And that's why I'm putting you through this trauma. I'm sorry, I don't want to scratch your head, but guys, we're done. Okay. I'm not going to give you the whole thing, so don't wait for me.
That's you asked me a question.
So we want to find the closest pixel in every layer. Pull out the AOD 550 for that pixel. First step. everyone has this at least.
Yes.
Station, latitude, longitude, and that nobody put a positive 73 point whatever, that is negative. Positive would indicate east. New York City, 73 west, or about 74. Okay. So now, like I said, start one step at a time. Don't jump straight in the for loop. So the distance matrix, the square root of CCNY lat minus, what's the name of my thing? F. Minus lat F, so all the rows, all the columns of layer, let's just say layer 1 for now. Nah, you know what? Layer K, I'm going to start with K equals to 1. Yeah? So make sure I keep track of my parentheses here so I don't get an imaginary or complex number later on. Plus spaces. Gotcha. Thank you. Again, don't wait for me. I mean, I'm assuming most of you should have gotten this already. This is just for whoever, for some reason, if you couldn't get this far, now this will give you a boost. Okay?
Forgot the first word.
Let's see, what did I forget? Square. Yeah. Anything else? I know the index is right. That's right. Notice when I click by a certain parenthesis, it underlines the corresponding one.
Yeah.
So I can know where I am. Yeah, so I'm good. Now, let me run it and just see what I get. I want to know what I'm doing here. So I go to dist. I see I have 203 by 135. These are all the distances. Okay. Cool. So I get what I expect here. I don't get any complex numbers. Now, I don't know what to do. I say help min. Hold on, just pay attention to what I'm doing right now, and then I'll answer the question. I look at the help section, I see that I can find the index of the minimum value, so I try it. Try that same terminology there. And I'm going to give it something else, I'm going to call it min dist or something. And then min dist int for index. And here I'm going to put, now there's a bunch of ways you can do this, okay? Not just one way. If I do this, this is going to give me the minimum of every column. And then the indices I get are going to be the row indices of every column. Every column's minimum. Okay? So you have to figure out your approach here. One way to do it is I could say, give me the global min of this one file, which is my first file. And let's see what I get.
Is that pixel element or index?
So I have a minimum distance value of 0.09.
Wow.
And the index is 24. So does that help me? Well, I want to test it, right?
Okay.
Let's just check what my AOD is there. What do I get? Don't just copy me right off the bat. Okay. Wait, I want to see something here. Okay. So did you get this far? Did you use the minimum function to get that?
Yeah.
So if you didn't, start with something like this and play with it. I just want to check something because I have a difference here between my two computers, so I'm going to check.
I don't have to do that. I can change the process.
Why don't I check my my latitude? Pretty far. Do you guys get the idea? If I can do it for one, I can do it for all. And if you get an index value, you can check what the latitude is, what the longitude is. Only thing I'm skeptical about is that I'm getting a different minimum distance on this computer than I am from my computer. So let me look.
I'm getting the same.
Yeah, you're
You're
getting
getting
that
the same,
Yeah.
but what you have, yeah. You're getting different, you're getting the same.
What are you getting on the CCNY computer?
I'm getting a distance of 0.09. On my computer, I'm getting 0.02. So let me see the file that I'm looking at.
Getting 0.09.
File list. That name.
Oh, that's why.
Is it because you're using three-dimensional longitudes and latitudes? Okay.
They go from one.
Okay, got it. Okay. So now just bear in mind, we're going to make this simpler than it should be. You would probably want to set a threshold on your minimum distance. So if your minimum distance is like too high, that means maybe you're too far from CCNY, the closest pixel. You might not want to include it. So you would set some kind of threshold. Remember how we had a valid range for the modus data? You do the same thing for these distances. If my minimum distance is not within this valid range that I'm looking for, I'm just going to set it, I'm going to reject it. Right? But for now, let's just keep it. Even to me, this is maybe a little far, a bit far. We'll keep it, okay? But in reality, we set a threshold.
What would the threshold be?
Depends on how accurate you want to be, right? So, I mean, right now we're dealing with decimal degrees, and so I would say you have to do some calculation on the threshold distance you're willing to work with, right?
So what was yours that you said it might be below
0.09.
and 0.02 would be acceptable? Because I want to know if it's like order of magnitude or is it like in years?
I would say,
When I did K1 and 5, I got
ideally, you want it within 1,000th of a decimal degree. I would say, right? The more accurate, the better. But it depends on how much leeway you're willing to give, right? It depends on the nature of your analysis, I would say. Okay? But the thing is, if you're too strict on that threshold, you're going to have a lot less points at the end to plot, right? So you need to compromise, I would say. Okay, so check it out. My index is here. Now look, there's a couple ways I could do this. Let me just say modus, yeah. Modus, CCNY, AOD. You can name it whatever you want. Then I would say K equals. Let's see if this works. I'm actually writing it a little differently than I usually do, but I think this could work. So let's try it. Actually, not work. This won't work. Why? Because AOD 550 is a 3D matrix, right? Okay, so let's add a line here. There are a couple ways we can do this. We could put in an index that corresponds to the row and column in that particular layer, or we could specify the row and the column in the layer.
Which AOD 550 is the one?
Okay.
So the AOD 550.
That's what I'm saying. This won't work because this index is going to correspond to every corresponding layer that we're dealing with. That's what I'm saying. This is my final, and that would be wrong. Okay. So here's what we want to do. We want to get our row index, our column index, which we didn't define yet. I'm just writing it in now for layer K. And if you copy these straight off the bat, you're probably going to get errors in your code. So beware of that. What you should be absorbing is the approach, not copying word for word, character for character. Okay? Now there happens to be a function, like I said, there's so many ways to do it. There's one function called end to sub. So my approach, I find the single index value for that layer. It's just one value. What is it in this case? You can all tell me if you have it. 24255. Okay, if I use this function called int to sub, it converts an index, that single value, to the corresponding row and column. So let's see how that works. Help int to sub. It tells me, okay, if I give it the size of the current matrix I'm working with, and then the index that I have, it'll give me, as results, if you type this in your own command window now, because I can't show the whole thing, it'll give me the equivalent row and column that corresponds to that index. Right? So we're trying to find position. No. That index, that 25,000, whatever it was, it's an index. I want to know what that row is, what that column is. Not all the rows, not that one row and that one column that corresponds to that index. And this function will do it. It just needs to know how big the matrix is. So what should I input here? Looking at that help. What should I put? So I want the row index, and I want my column index to be the outputs, and I'm going to use the function into sub. Again, this is just one approach. There could be many alternative approaches. Into sub. What do I input? The size. Size of what?
Distance size?
Matrix.
I have some different options, right? We have a three-dimensional matrix and we have our temporary two-dimensional matrix. Right now, for one step, for one file, dist is two-dimensional and it's 203 by 135. Is it not? Check your workspace.
Yeah, 205 by 135.
And that happens to correspond to the same dimensions as each file. I could use that. Or even my final three-dimensional matrix, when I specify one of the files, one of the layers, that also has the same number of dimensions. I mean, same dimension numbers, 203 by 135, right? So I could just pick one. Any of them would work. As long as it gives me 203, so I could even write this. Square brackets, 203, 135, but I prefer to put in something that, in case we ever wanted to apply this to something else, it would be able to be dynamic. So size of this. And if I forgot what that output would be, I could highlight this little section and see what I get to make sure I'm right. Oh yeah, that's right. It would give me 203, 135. And what's my distance? My distance index? Oh, that's the index. So it knows how many rows, how many columns. It takes your index, converts it to a row and a column number. Let's see what I get. Okay, that's row 98, column 120. Is that right? Let's check. We don't know, right? You don't know if it's right. I think Barry is saying, I don't know if it's right. Well, we got to check. Let's see. Let's say flat F, my final 3D. Take my row index. I called it row end, my column index, column end. For the first file, let me see what I get. Okay, that's my latitude. That seems pretty close to CCNY's latitude. Okay. And let's see for the longitude. -74. All right, that's a little far, but again, I said we're not going to consider the thresholds for simplicity. Okay.
Maybe it's because we use for functions.
So that matches what I found. Let's see, what was my, that should be the same thing as this. least for the first layer. For the first layer, it should be the same, yeah. It won't be the same for the second. Okay, so you see what that function does? It takes an index, converts it to a row and column. Now I know the row, now I know the column, now I know the layer. Okay? And these are temporary. Why are they temporary? Now, I just tried this for k equals 1, because I said star simples, try for one file. I just saw that it works for one file. Let me see what, when I run this final line, what my AOD would be. Oh, oops. Oh man, I'm just screwing everything up. Let me get back. Okay. What do you get for the AOD at that pixel? For your first file, your AOD 550 file, if you tried this approach, you have the location of that closest pixel. Now you just type that row, column, and layer number in. What's your AOD? See how where I entered it? I get the row, I get the column. I know my layer is layer K, which I set constant to 1. And now I could reference that one value. AOD 550 is my final AOD. I reference the row I found, I reference the column I found, and I reference the layer. Specify. This is just one value. This is just one value. This is just one value. So I should get that one AOD value that's there. I get 0.15. What do you guys get? Do you get that?
0.15.
What do you get, Nicole?
Yeah.
Okay. All right. What do you get, Evelyn? 540 or 543? No, I'm messing with you. What do you get, Aaron? You got Nan. Okay. What do you get, Juan?
Give me 1 second. I'll come back.
What do you get, Sean? Error. Okay. Okay. This again. This is one way to do it. There are other ways. It's not the only way.
Yeah, I got Nan.
You got me too?
Yeah.
Okay. Let's see.
Oh wait, give me 1 second. I'm gonna get wrong.
Oh shit. I got the colors in
Why was I sure?
Wait, now it goes 1.15.
You're right.
Hey, switch to what?
I couldn't find the right one that I can use. None of them works for me because it's something different. But after that you have
No, just filter. That's all. You see the triangle? You see the other side? You have to match.
this is
See now? You have to know which one is there. You have the triangle there, right? Yeah.
I named this one already.
Okay, so but combine them up. Combine them up. You see the triangle there?
This?
Yeah. So try to match it. How it's located there and how it's located here.
But I don't see this one on my map. I don't see it. Well, this?
No, you look.
This?
I didn't mark it.
Oh, okay.
have two lower side to plug into.
And that one, is a high school.
Hey, you copy. So this, what's the name of it?
There's the name of it. In the map.
You can read it?
Hey, Philip. Grassland High School.
PowerPoint's already done.
But how much you get?
Which one?
The operations.
And this stuff, can't you run the comment?
Rowing, calling.
Yeah, comment.
Rowing 98. Call in 20.
You can pass 6 points, recent, limited sunset.
Row. What about the last one? You got the right answer?
Yeah, I did a different way because excuse me.
You mean this one?
Yeah, no, how much is that?
98.
Before that.
Oh, before that.
Just make sure you can get the AOT value.
You want from here?
Because we use
You want this?
same result here. But then when we start doing this, I have
For this one?
just for this.
Okay, so you put the size. You put the size. Oh, this one, but yeah, you need to put the size. Then your distance you put D, right? That's fine. Then your mind is put R. Yeah.
Ah. I start liking Matlab when it's like the last class. Yeah, I just
Yeah, just double check that. Be careful.